Hello and welcome to the webinar on Lessons Learned from a Reduced-Tillage Organic Cropping Systems project by William Curran, Ron Hoover, and John Wallace of Penn State University. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. You can find all of our published articles, videos, and our many upcoming and recorded webinars on organic farming and research topics on our website at extension.org/organic_production. We're very glad to be able to welcome William Curran, Ron Hoover, and John Wallace as our speakers today. William Curran is a professor of weed science in the plant science department at Penn State, where he has a research extension focus in agronomic crops. Bill's statewide extension program focuses on providing agricultural constituents with the latest weed management information. Ron Hoover is the coordinator of on-farm research at Penn State University, where the focus of this program has been to increase rates of adoption of new and underutilized technologies related to field crop production and soil management. John Wallace is a postdoctoral research associate in the Plant Sciences Department at Penn State, where he serves as a project manager for the Reduced-Tillage Organic Cropping Systems project.
Okay, thank you, Alice. We are interested in telling you about some of our experiences for a project that's winding down. So the title of today's is Lessons Learned from the Reduced-Tillage Organic Systems Experiment, which is a project that was started in 2010 here at Penn State, at the USDA in Beltsville, and then also at the University of Delaware and some other collaborating institutions. And so we thought it would be useful to sort of review some of our experiences from this project, and hopefully bring home some of the lessons learned. Let's see if I can advance this. Okay, whoop, too far, one back here. There's been a number of individuals involved in this. I mentioned the USDA in Beltsville, the University of Delaware, Cornell University, and then we've also had some collaborators at NC State, a number of farmers. Of course, we have Alice today and John from Oregon State University, and then we've worked with some county-based educators. And we would also like to thank the USDA OREI program. They really are the folks that enabled us to conduct this project, and so we think it's been a very successful project, and we're certainly very appreciative of that. So what we're going to do today is we're going to go through a little bit of the rationale, how this project started, tell you about some of the objectives and methodology, and then really we're sort of going to focus on expectations, what we thought would happen, and actually what did happen, both for some of the research farm or the on-station work, and then also for the on-farm work, and then we'll finish up with some summary comments and maybe some recommendations. So I'm going to lead things off. John's going to take the middle, and Ron's going to take the end. For those of you that aren't from the Mid-Atlantic region, we're sitting here in the central part of Pennsylvania at Penn State University in State College. So we're sort of on the northern area of the Chesapeake Bay watershed, which is a very important historical watershed for our region. There's around 15 million people that live in and around the Chesapeake Bay, so a fairly populated area. But there's also a lot of diverse agriculture, from grains to vegetables to livestock. There's a lot of no-till enthusiasm and a fair amount of adoption of that, as well as a lot of interest in cover crops. So it's a really interesting area to live and work in if you're in agriculture. There actually are some pretty successful programs, some incentive programs for both no-till and more recently for cover crops. Particularly Maryland is always brought up as an example of a state that has a very successful cover crop incentive program. And we also are blessed with lots of ag diversity, interest in sustainability, interest in organic. Again, there's a large population on the East Coast that really appreciates some of the things that we do in agriculture in this area. So we have a bit of a challenge certainly in organic production, and we're really focused on organic grain production here today because tillage is historically been a big part of that. It's been really the backbone for weed control, whether we're trying to suppress perennial weeds with a moldboard plow, where we're coming in and we're using some sort of blind tillage or maybe a inter-row cultivator for control of annual weeds during the summertime. It's also very important, our farmers use it to incorporate manures and composts, and we know that it can have a pretty profound effect on insect pests and management of some plant diseases. Historically, it's been used to terminate alfalfa in our region, and then also to incorporate green manure cover crops, which would be commonly found on most of our organic grain farms. So tillage doesn't have to go hand in hand with organic, but certainly it's been historically an important part of it. And we know that there's a number of benefits to trying to reduce tillage within these systems, and those would include the obvious one, which is the first one, protect soil against erosion, loss in soil quality. And secondly, there's been a lot of interest in looking at energy, and particularly with energy prices increasing. We know that if we can adopt or make these rotational no-till or no-till systems work, we can save costs, we can reduce labor, we can save energy. And so this is a graph actually from Matt Ryan, one of the collaborators on this project. He did his PhD here at Penn State. This was part of his PhD work, and he compared what you might call a traditional organic grain production system, corn, soybean, and wheat, to a rotational no-till system that we'll be talking about today. And that's the amount of energy use in those two systems. And basically, you can see the rotational no-till system. You're primarily saving diesel fuel costs and also reducing some of the labor. So we certainly know there's some value in a number of different ways if we can identify ways of making this work. There also are some potential barriers, right? Otherwise, everybody would be doing this. Here in the central part of Pennsylvania, if you look at that, the map of Pennsylvania down below, we really have some challenges as we move northward through the Mid-Atlantic region and certainly up into New York or into New England in terms of growing season length. One of the things that you'll see in this project is that we're really trying to utilize cover crops. And when we get into some of these more northern climates, those windows of opportunity for establishing cover crops become much more narrow, and so that can be a challenge. Also, it's difficult to maintain good weed control, and so the graph in the upper right is from some work that was done here at Penn State 5 or more years ago now, looking at transitioning to organic, where we compared a full tillage system, a moldboard plow based system, to a chisel plow based system, which is the Reduced-Till. And basically that shows perennial weed biomass or dry matter in those two systems. And biomass in this case is primarily made up of Canada thistle and hedge bindweed. And so we really had some challenges when we tried to reduce tillage in those systems and moved away from a moldboard plow. And then thirdly, certainly we know as we reduce tillage and we have more residue, we can have potentially more insect and invertebrate pests, and we have a nice picture of a slug, one of our more common invertebrate pests in this area of the world. So there are a number of approaches to reducing tillage in organic systems. I think we're all agreeing that at least at this time, at least in certainly annual row crops or grain crops, continuous no-till is really not realistic, at least at this time. But there are some other ways that farmers do this and try to do this. And probably first and foremost would be using a perennial crop like alfalfa. It's in there for 3 or 4 years. You're not tilling the soil, and so that really makes a lot of sense. We have a lot of farmers that are grain growers and don't have the equipment or maybe the time to deal with forage crops, and so they're very interested in focusing on the grain part of the rotation. There's opportunities to reduce tillage intensity, moving from a moldboard plow to a chisel plow. I showed you the graph in the previous slide. One of the problems that we've had here is encroachment by perennial weeds, and so that has some challenges. And so the third option that sort of we've been talking about is reducing tillage frequency, and that's really what the project is that we'll be discussing today. And primarily we're doing that by using cover crops in the system and trying to incorporate other cultural practices. So this work really started almost 10 years ago here at Penn State. We actually attended a field day at the Rodale Institute in 2004 and saw one of these contraptions on the front of this tractor, this roller-crimper, at their field day, and got really excited about this, and we're very interested in looking at how we might terminate cover crops without using herbicides. And so we built that orange roller in 2005 and sort of embarked on a number of experiments. From that point on, this is a picture actually showing Stephen Mirsky, who's at the USDA in Beltsville now, a research ecologist down there, who did his PhD here at Penn State, and then also Matt Ryan, who's listed there. And so we started doing some experiments looking at termination timing and seeding timing in the fall, and seeding rates and fertility and a number of things with cereal rye. Also Ruth Mischler, who was working on a master's degree here, did quite a bit of work with hairy vetch. And so that sort of led us down this path of getting to know how to manage cover crops with the idea of hopefully maybe being able to use these in our organic systems experiment. And so we did all this component research looking at individual pieces, and then starting in 2010 we tried to put this together into a rotation experiment. And so that's what we'll present today. We call this the ROSE experiment, Reduced-Tillage Organic Systems Experiment. And really there's three primary objectives. It's to test the feasibility of some of these practices in a system before we really had gone into fields for single years or maybe 2 years and then sort of moved out beyond those. And so now if we're producing problems in year 1, we'll be able to track those in year 2 and 3 and so on. That becomes really important, as you'll see. We also wanted to determine if manipulating the time of cover crop termination and cash crop planting would help manage weeds and insect pests. And so that's a big part of this experiment. By altering planting date in the springtime, are we better able to manage these weed and insect pests? And then really a big part of this is how geographically specific is this. And so we were interested in looking at this across the Mid-Atlantic region, and so we have a pretty broad area that we're sort of addressing. So here's the Mid-Atlantic region again. So we're conducting this, at least the research station project on 3 farms here near State College, Pennsylvania, in the north, near Beltsville, Maryland, in the middle, and then Georgetown, Delaware, in the south. It's a 3-year full entry cropping systems experiment. So that means that we have every crop in every year. I'll go into a little bit more of that in a moment. And you can see that we range from about 3,000 degree days in State College down, or up to 4,350 down in Georgetown, Delaware. So we're basically gaining 600 to 700 degree days from north to south as we go from State College to Beltsville and then Beltsville to Georgetown. In addition, we've been doing on-farm trials, and Ron's going to talk a little bit about that near the end. We've been doing those trials in Pennsylvania, Maryland, and North Carolina. Today we'll just be talking about the Pennsylvania work. So the 3-year rotation I mentioned is corn, soybean, and wheat. What we're doing is we're planting no-till corn and no-till soybeans, and we're using either hairy vetch or triticale in the corn situation or cereal rye in the soybean situation as a weed suppressive mulch. And so that's why these cover crops become so important. We're relying on them really to do the bulk of the weed management, and you can see some no-till corn planted into rolled hairy vetch and triticale, or soybeans no-tilled into cereal rye, and the large amount of mulch that really becomes key in helping suppress the weed populations. I want to make sure everybody is aware that this is not a continuous no-till system, and so we are still using tillage, and in fact in this experiment we're using the moldboard plow. So we're moldboard plowing every year in this experiment. So we moldboard plow after we harvest the corn, before the cereal rye. We moldboard plow after we harvest the soybeans, before we plant the wheat, and then we moldboard plow after the wheat before we establish the hairy vetch. And actually 2 out of those 3 were applying manure at the same time. So the plow really in our situation is to help suppress perennial weeds. We're concerned about Canada thistle and bindweed and things like that. And then also we're incorporating manure at that time for our cash crops. So again, it's not a continuous no-till system, but if you were to compare this to sort of what a traditional organic system with this type of rotation would have, there would be many more plowing events and obviously lots and lots of secondary tillage and subsequent cultivation. In addition to the plowing, though, we also are, at least in some of the treatments, using this high-residue cultivator. And so this is sort of our backup plan for weed control. In half the plots, we come in and we cultivate the corn or the soybean, and we usually make 2 passes with that cultivator. Sort of 5-6 weeks into the season, you can see the corn's maybe a foot tall there, maybe a little taller than that, to help control the inter-row weeds. So this is sort of how the experiment is laid out. There's really 3 parts to it. The first one is planting date, and we're calling these an early, a middle, and a late planting date, and that's only happening in the corn and the soybeans. The wheat is all planted at the same date. We're not really looking at weed management in wheat very much. But basically, the cover crops are terminated by rolling at these 3 different dates. And so we do it at the same day that we plant corn. Or actually in soybean, we're doing it a week prior to when we plant soybean, and John's going to go into that a little bit more in his part of the presentation. But we're basically rolling the cover crops and planting our cash crops. And if we look at those early, middle, and late dates, they're about a week apart from one another, so a week to 10 days, something like that. And I'd also mention that really the initiation of those dates is based on cover crop phenology, when we think we can roll kill it. And it's quite different in Delaware than it is in Pennsylvania. And so actually Delaware is about a month ahead of us. So while we might be waiting until June 1st to roll some of our cover crops, in that same timing at Delaware, it might be the 1st of May, and then Maryland is usually somewhere in between. The photo that you see a late planting date on the left and an early planting date on the right. I mentioned the high residue cultivation. Again, just sort of to supplement things, and we're doing that in half the plots. So half the plots get cultivated and the other half don't. And then the last component is variety maturity, where we're looking at different varieties based on those planting dates. And so this shows corn and soybean for Delaware and Maryland are using the same maturity dates. We're planting longer maturity varieties at the early dates and shorter maturity varieties at the later dates. So we're trying to fit in variety maturity with those individual planting dates, and it shows you some of the groups that we're using, that either the maturity day or group that we're using for both corn and beans in this experiment. So I'm going to turn the program over to John, and you will see that things don't always go as planned, but certainly we're learning as we go along.
All right, thank you, Bill. So as Bill mentioned, there's really been a long series of research and studies, smaller component studies leading up to this systems experiment at Penn State. And so we did have some expectations as far as what would happen in the field, but really at this point it seems like some of the real important outcomes of this study have been things that didn't go quite as expected. So the next series of slides, I'm going to go through a series of expectations, and then I'm going to follow that up with some results for each of those expectations and lessons learned.
Unmuted.
John,
let me give you the control again. It seems to have gone off, so just try clicking on the screen right now and should be able to have it. Okay, now use your arrow key to advance down. Yep, there you go.
Okay. Thank you. Okay, so our first expectation involved
Muted.
effectively terminating cover crops And so Bill mentioned much of the component research was really learning how to use the roller crimper to terminate cover crops leading up to the systems experiment. And so the expectation, based on the previous research, was that there was going to be a window where we could effectively terminate the cover crops, and that window was going to be wide enough and where we could delay cash crop planting, and by delaying cash crop planting as a means for managing pests in the early season. Oops. Okay, so Bill and a graduate student, Ruth Mischler, a few years ago worked on the optimal termination timing for terminating hairy vetch. And what they found was that you really reached consistent control with the roller crimper somewhere between 100% flowering and an early pod set with hairy vetch. And so the strategy with the rows experiment was really to align this effective point of termination with the middle planting date. And so the early planting date and the late planting date went somewhere before and somewhere after this consistent control period. And so one other thing to note about this is this transition between different growth stages from the vegetative state through flowering and early pod set coincides with a period of really rapid growth of hairy vetch in late spring and early summer. And so there's more than one factor to consider as far as when you're going to terminate your cover crops. As I'm going to show in the upcoming slides, as you accumulate more biomass with the cover crops, that usually leads to greater weed suppression. So there's a trade-off between timing your termination to at a point where you can get consistent control of the cover crops, but yet achieving adequate biomass to suppress weeds. Stephen Mirsky did similar work for his PhD on cereal rye. He looked at different timings for termination, and what he found was after you've reached flowering, you started to get pretty effective control, greater than 85% control of cereal rye. And so we followed the same kind of strategy with the rows experiment as far as trying to align the middle planting date with this period right here, and the early planting date went before and the late planting date after. Should also note that as far as scouting in the field for timing of cereal rye termination, this is going to be somewhat more difficult than hairy vetch because flowering is somewhat inconspicuous with cereal rye. The same trade-offs exist with the cereal rye, where they can accumulate a lot of biomass in a period of 10 to 14 days. You can, in say mid-May, you can accumulate up to about 2,000 pounds per acre of cereal rye over a 10 to 14 day period. So what we found in the field was that one pass was not enough. Those previous experiments I just showed utilized one pass with a roller crimper to terminate the cover crops. And so based on our experience in the first year of the study, we decided that two passes were needed to improve control. So these two passes were made about a week apart. And in corn, we terminated hairy vetch with the first pass and planted, and then came back a week later and terminated or rolled again. And with soybeans, we made one roll, came back 1 week later, rolled a second pass, and then planted soybeans into cereal rye. And so what we found with the results is that really we have a pretty narrow window in which we can control these cover crops with the roller crimper. And there's a few scenarios that we found in which you have volunteer cover crops later in the rotation. If you roll too early, you have regrowth, and so the regrowth leads to a mature seed set, and that enters the seed bank and can become a problem later in the rotation. Or conversely, if you roll too late, you may get effective termination of your cover crops and not much regrowth, but those plants may already have mature seed and then become a volunteer issue later in the rotation. So because there's this fairly precise window, it may be necessary to basically minimize the number of volunteers you have later in the rotation. Here's a few pictures to illustrate what went on in the field. So this is at Penn State in 2011. We're planting corn into rolled hairy vetch and triticale. On the left, you see the early planting date treatment, and on the right, you see the middle planting date treatment, and you can see that we have significantly more regrowth of hairy vetch at the earlier planting date in comparison to the middle. We saw the same kind of trend planting soybeans into rolled cereal rye. On the left, you have the early planting date, and on the right, the late planting date. So you can see a significant amount of regrowth there in the early planting date, where in the late planting date, we got pretty good control. And this picture really gives you a good indication of how much residue we're really dealing with in this type of system. So in most cases, the regrowth that we saw with the cover crops was minimal enough to really not have an effect on crop yield. But in some cases where we didn't achieve good control, mostly at early planting dates, and we had really high regrowth, that could lead to negative impacts on yield. This picture just illustrates that. This is at the Delaware site, the early planting date, and this is hairy vetch regrowth in corn. Here would probably be a good point to apologize for all of you who are going to be scratching your head as I go forward, showing figures and trying to do the math as far as the metric units. So I'll try to give you a good point of reference with these figures. So you can see with the Delaware corn yields that in the cases where we didn't get good cover crop termination, we had high regrowth, we had significantly lower yields in comparison to the timings where we got greater termination or more effective termination. And so this would be about the middle planting date here at Delaware would top out at about 95 bushels. Okay, moving on to our second expectation, and based on previous research, we expected that the standard no-till equipment that we were using was going to be sufficient for establishing cash crops. What we found, however, in many cases that we needed to make modifications to our no-till equipment in order to really slice through these high residue environments and open a seed furrow and close a seed furrow. And in many cases, this was due to an interaction between the high residue environment and the cover crops kind of modifying the soil surface. And so we were dealing with issues where the soil was really too dry or too wet, and too wet the case being where we weren't able to get good seed furrow closure. This picture is a good illustration of dry conditions. What happens with cereal rye is it does a pretty good job of sucking up soil moisture late in spring and in early summer. And you're planting through really high residue environments and into dry soil, and you're really not getting a good penetration and a good seed furrow. And in many cases, you would have soybeans sitting on top of the surface. And so poor populations were somewhat related to high residue environments. So in situations where we had a lot of biomass, that led to a decrease in soy in crop populations. This figure illustrates that. It's from the Maryland site in 2012 and 2013 across the different planting dates. The figure shows on the x-axis you have rye biomass. So we're topping out here at about 10,000 pounds per acre of rye biomass. And on the y-axis we have soybean plants per hectare on a log scale. To give you a point of reference, our target population was about 225,000 plants per acre, and so these populations were approaching that target population. And so really there are situations where we have too much residue, and that negatively affects population stands, particularly in the soybeans. This relationship's pretty straightforward, of course. Where we saw poor population stands, it led to poor crop yields. And so just to illustrate that, we saw a pretty consistent trend at Delaware in 2012 in soybeans, in Maryland in 2013 in corn, where we saw the variability in crop yields could be explained by the population stands. And so, though this is fairly straightforward, it's important to note that the variability that we did see in crop yields across the study sites and across the years, we think is largely due to poor population establishments and some of the technical aspects that are related to that. As far as planting equipment goes, and not necessarily due to weed or insect pest problems. And some of those challenges we don't think are insurmountable, and so we did make some improvements during the course of the study. Some of those were that we added some additional weight above the planter boxes. As shown here in this picture, in order to really make sure that we're slicing through that residue and creating a good seed furrow. We swapped out coulter types, moving to a ripple style from a wave style. The ripple style was more effective at slicing through the residue and creating a more narrow furrow. There's some other issues or some planter adjustments that can be made. It's definitely important to switch from a full till to a no-till closing wheel. And then there's also residue management type equipment that can be manipulated based upon the system that you're working in, whether it be different row cleaners or different trash wheels. Okay, moving on. Based on previous research I kind of mentioned earlier, we expected that a delay in planting date was going to result in greater weed suppression. And so we've seen pretty consistent trends in the past. This figure shows some work that was done in rolling soybeans and rolling cereal rye and no-till planting soybeans. And you can see that as you delay planting dates from late April to mid-May in Pennsylvania, this led to about a twofold increase in cereal rye biomass and a pretty significant decline in overall weed biomass. What we found in the study was that we did not really see a linear increase in cover crop biomass accumulation with increasing or delaying planting date. And this was due to the fact that the way the study was set up, the early planting date was late enough that the later planting dates, really we were seeing some senescence in the cover crops, and in cases where we really had high precipitation in the spring at Delaware and Maryland, we actually saw some of the cover crops starting to break down. And so we didn't see a real consistent trend between cover crop biomass and weed abundance, and so this is we think is due to some of these other factors that were going on related to cover crop management, how much regrowth we had, what the volunteer cover crop situation was, as well as what kind of crop population stands we were getting. We also expected that supplemental weed control with a high residue cultivator was going to be necessary to really maintain high levels of weed control below a point which would negatively impact crop populations, or I'm sorry, crop yields. What we found in the results was that the shallow high residue cultivator was really very effective at reducing weed biomass. These two pictures on the right is a nice illustration of the high residue cultivator in action. This is in Delaware in corn, and you have the high residue cultivator treatment above, no cultivation below. And so in situations where we had high weed pressure, the cultivation had an impact on yields. But in situations where we did not have a significant amount of weed pressure, the effect of the cultivation was either negligible on crop yields, or in some cases it actually decreased yields. This figure gives you a little bit of a background or a picture of what was going on as far as weed pressure at the different sites. We have weed biomass on the x-axis, and then we have within corn and soybean at each of the 3 sites, we have a comparison between the cultivation treatments. Here we have cultivation and the no cultivation control. And so there's a number of things to point out as you move across this figure. One is that the cultivation consistently lowered weed biomass in comparison to the no cultivation treatment, but the weed composition in the different sites were quite a bit different, as well as the actual abundance of weeds, where we had significantly lower weed pressure at Penn State in comparison to Delaware and Maryland. The last expectation was related to pest avoidance, and so our expectation based on previous research was that delaying planting date would decrease crop injury related to early season insect pests, and we were particularly interested in these early insect pests that really like high residue environments. So an example of this would be the black cutworm. The black cutworm adult moths migrate from the south to the north, in say late April or early May within Pennsylvania, and they lay eggs in the period between the point at which they migrate and where you see larval damage on crop populations. Has been modeled, and so we understand that relationship, and so delaying planting date is actually a way to avoid that early season pest injury. And so that was one of the things we were trying to really look at within the rose experiment. And what we found, in summary, really was that early season pests did not reach damaging levels. And so we contributed that to the fact that there was pretty high numbers of predators at our site. And we did see a trend towards increasing number of predators as the years went on. So this figure provides a little bit of background. This is data from the pitfall traps that were monitored, and so we have the mean number of predators in blue and the mean number of herbivores or insect or invertebrate pests in red for each of the planting dates and across the 3 different crops in the rotation. And you can see that we have significantly more predators than pests at each one of the planting dates. The predator abundance tended to be higher in the corn in comparison to soybean and wheat. And at least within corn and soybean, there seems to be a trend towards increasing predator abundance as you delay planting date. And finally, we did see, at least in parts of the cropping sequence, that we saw greater predation levels with as the years went on. So this shows the proportion of damaged caterpillars, which were monitored with using sentinel traps, and you can see a significant increase from 2011 to 12 to 13. With that, I'm going to turn it over to Ron, and Ron can tell you about some of the expectations and outcomes related to the on-farm projects.
Okay, thanks, John. As we've heard so far in the presentation, there's been a lot of work done on the components of the studies. And what we decided to do with the on-farm work, and again, we're going to focus on the on-farm work that I did here in Pennsylvania. We did do some work, as Bill mentioned earlier, in Maryland and down in North Carolina, but our focus is just going to be on the Pennsylvania work. We worked on 2 farms, one about an hour south and east of us here at State College, the Rank family farm in Mifflin, Pennsylvania, and the other being the Reichert farm, another hour further east of the first farm. We worked on these 3 farms all 3 years. We did set these trials up as true replicated studies. The studies were pretty straightforward, where we were looking at taking a look at some of the best components that were coming out of the study that was being done back at Rock Springs, back at the on-station experiment, the Rose experiment, as well as previous work here in Pennsylvania and in the region, and comparing that to what the farmers had been doing over the years, and that being the heavier tillage. And so it was a basic question: what are the challenges to making no-till work or rotational no-till work on our farms here in the Mid-Atlantic? So what we'll do is we'll take a look at just a few studies here. We don't have time to go through all of them, but dovetailing my comments into some of the comments that John shared just a moment ago, and that was we had several expectations. One had to do with whether or not we could get the crop into some of these high residue situations. And here we have a picture from the Reichert farm back in 2011, where the goal was to take cereal rye, roll that down, and get soybean established into it. And for the most part, we did have a crop, but we were challenged in getting there. The picture on the left takes a look, or shows the residue as it was rolled down just prior to just prior to planting, and then the planter had already gone through. Picture on the right maybe a little tough to make out, but you can see some cut residue here in the bottom part of that right slide. The seed finder in an area where it was just tough to cut through the residue by virtue of how much was out there. But when you come back a few weeks later and you take a look at the beans, we find that we did get some establishment there. And actually, this is one of those cases where sometimes it's better to be lucky than good. What ended up happening was, although we didn't cut the residue as well as we would have liked with the planter, we ended up with beans that made their way down through the residue. Being that it was as heavy as it was, roughly 6,000 pounds per acre, we ended up, and because we were followed with a few timely showers, we ended up having some germination of some seed that probably wouldn't have germinated had the conditions been a little bit drier. And if we take a look at that later in the season, we did take this one to yield. You see some beans there in early August. You look across the field, both sides of whether it be rolled and no-tilled or where we did do the tillage and cultivation. Very few weeds sticking up above the bean canopy. We did take it to yield, as I mentioned. We did record 42 bushels per acre where we did do the no-till, compared to 37 bushels where we did do the full tillage followed with cultivation. All in all, a pretty successful trial. Not as high yield as what we would have expected, but we also need to note that 2011 in that part of the state was actually fairly dry. Change gears here a little bit. This is a more recent trial that was conducted on the Rank farm in fall of 2012. A field was selected where the Rank family had seeded some crimson clover, hairy vetch, and triticale, about 20 pounds each of the legumes and about 90 pounds of the triticale. They got planted the last couple days in August. You see a picture on the left where showing the nice canopy that we had in early October, and then the picture on the right showing about 30 inches of growth in the early part of May 2013. So a lot of biomass there. Again, you know, the challenge was, can we get through that? And that's where the fun started. The goal at this time was to try something that some of our conventional no-till farmers are getting excited about, and that is, before killing the cover crop, in our case we're using the roller. In the case of the conventional farmers, they're oftentimes using the herbicide program. Before killing it, or in our case putting it down, could we plant through it, maybe not have such a great challenge in trying to get that seed furrow opened, not having so much residue to cut, and then come through later with the roller and roll it down. That just did not work here. We had plenty of residue, over 6,500 pounds of biomass. The picture on the left shows a futile attempt at getting the planter through that mixture. And eventually what we ended up having to do was, after stopping and unwrapping apparatus that was, for the most part, held up out of the way, but still was capable of catching some of that biomass, we abandoned that idea, and the picture on the right shows the roller coming through and actually rolling, not just where we did struggle to get a couple passes planted, but to finish rolling down the rest of the field. And we take a look at the corn later in the season. This picture taken in the early part of August. Both pictures are actually where we did roll the cover crop, and you can see a little bit better on the right. Lots of residue there at that time of the season. Again, it was a drier season. We didn't enjoy quite as vigorous growth on the corn as maybe we could have had we had a few more inches of rain. But yields that were respectable, 119 bushel where we did roll and no-till versus 137 bushels where we did do full tillage. The one thing to note, and you see in the foreground on the picture of the right, the planter did still struggle. We struggled to try to get some of that seed where it needed to be, and so that stand overall was probably an 85 to 90% stand when you compared that to the 31,000 drop that we were attempting. So those are expectation twos, as outlined earlier in the on-station trial. Expectation three was that we would have good weed suppression with our rolled cover crops, and that is that you know, we would have good heavy covers. They would provide enough mulch that the season-long weed control would be enjoyed. In reality, on farm, it's a challenge to consistently grow that much cover crop. We need to be conscious of being able to get out there and getting the cover crop seed into the field early, so that we can get a good start, get a good vigorous start, and that we have enough fertility to drive that growth. This particular picture, again, was at the Reichert farm just this past year, where we came in with behind cereal rye, attempting to do soybean, and the growth it was tall, but it just wasn't very thick. Again, we tried the idea of coming in and planting into the standing green material and then coming afterwards to roll, and so you see the planter going through some of the standing green in the picture on the left. The picture on the right, actually the gentleman on the roller is pretty much chasing the planter across the field. And when you take a good look at the picture on the left, you can see we've got some bands there that just aren't very well covered with the rye, and that's going to show itself a little bit later to look like something like this. Just a lot of blow-throughs, as we say, a lot of opportunities for the weeds to come through the mulch. Picture on the left, you can make out the rows. We did have some pretty good rows of beans there, but we just didn't have the suppression of the weeds to allow those beans to really do what they were capable of doing. And when you stand on top of it, as evidenced by the picture on the right, where the cover was thin, you don't see much mulch there. That's where you open up and you know, you see the weeds growing up through. It's just a very dramatic difference there. And I added one more expectation. That was that maybe we could use these heavy no-till drills to come out there and do some cover crop drilling for us. I can make a very long story short. They're just not working. What we're asking a drill to do is just simply push too much steel into the field, given the weight of the unit. In fact, if you do the math, a drill with 7.5-inch openers, we're pushing essentially 3 to 4 times the amount of steel that a planter is pushing into the field. Planter with 30-inch spacing, assuming that the frames are about the same weight, we're just underweighted. And so the ability to cut the residue, open the furrow, place the seed where it needs to be placed, and then get that furrow, most importantly, get that furrow closed, is just not happening with the drill. And you might not know it, but behind the folks at the field day on the picture on the right are some drilled beans in there. Stand was very lousy, and actually the farmer, Mr. Reichert, eventually terminated that and turned that into some round bell silage. So in short, for us on farm to make this work, the two biggest limitations really come down to equipment. Do we have the capacity to cut a good heavy crop, get the seed where it needs to be, and close the furrow? And then the other limitation being, do we have enough cover crop there at the time that the cash crop is planted to be able to provide the weed control that we need to have, maybe not all season, but up until the point where that grain crop grows over and canopy's over and provides the competition, holding the weeds at bay throughout the rest of the season. And with that, I'm going to stop and turn it over to Bill.
Okay. See if I got control again. Yeah. So, whoops, went a little too far. So let's summarize where we are. So relative to crop yields, certainly they were variable across years and sites, but we did have success. And you can see some examples there in Maryland in 2011, 70 bushel per acre soybeans. We actually had pretty consistent 50 bushel beans in Pennsylvania. Corn grain was a little bit more variable across sites. That's a little more challenging system. Maryland, again, 140 bushels in 2011. Then corn silage, our best corn silage year was this past year, 2013, where we achieved about 18 tons of silage per acre. Insect pests, for the most part, weren't a big problem. We had an incidence of grasshoppers in Delaware the first year. We had some armyworm, as many of our conventional growers did in 2012, and then some slugs on occasion, particularly in Maryland and a few in Pennsylvania, but really not a big problem. And in fact, the beneficial insect picture was quite positive. Relative to weeds, we were worried about perennials. They didn't become much of a problem. Not that they won't in the future if the system continues, but we were pretty pleased with how our rotational tillage seemed to manage perennials. Certainly, if you have annual weeds, the high-residue cultivator was a useful tool where we had higher densities of those. We did have some problems in soybean that I guess I'll mention in the next slide, but that's a useful tool. So sort of the take-home recommendations from our project thus far, and I would say we're sort of still compiling, and there's 2 graduate students involved in this, and so we're in the process of summarizing data and writing lots of papers and theses, dissertations. But basically, hairy vetch and triticale are pretty weed suppressive cover crops, but the termination timing is really key, and particularly trying to avoid volunteer cover crops, and that becomes a particular problem in a wheat part of the rotation. And so in our corn-soybean-wheat rotation, wheat can be a real lure for those cover crops. Double rolling helped that situation, so that we think that is one possible tool that can be used to help prevent volunteers. I would say one of the big ones, and Ron just mentioned this, is the equipment, the no-till equipment necessary to work in these high-residue environments. That's a big take-home message. You can't just use standard no-till equipment, and you've got to play around with it. It requires a lot of testing and adjusting. I mentioned the high-residue cultivator, again, a pretty useful tool. We did have some problems in Pennsylvania, particularly in soybean, where we saw reduced yields. And it was in situations where we didn't have many weeds, so we didn't really need the cultivation, but it was part of the treatment, and where we ran into dry midsummer situations, and we opened up those soils, and we think we lost some soil moisture. Other management lessons, corn silage. We had to grow corn silage in Pennsylvania because of the narrow window, trying to get rye established after corn grain. We can't do that in the central part of Pennsylvania and north, so we're looking at corn silage. Delaware and Maryland, it was corn grain, and there's more opportunity where you have those wider windows. We didn't do a large number of variety tests. We basically didn't do a variety test in this study. We did look at different maturity varieties, and one thing that seemed to be apparent with corn anyway is there are some big differences in performance. It certainly pays to have good genetics, and certainly crop maturity goes a long way toward getting good yield. And I think, as most of our farmers would know by now, those later maturing varieties, those short season varieties, sometimes don't perform as well as longer ones, and so that was one of the things that we learned in this project. So with that, we'd like to thank you.
Move on to some of the questions here. One person wanted to know what is the best planter setup and row widths, and what brand of planter works the best?
Well, that's a loaded question. So I don't think there's a brand necessarily that works the best. For the most part, everything that we've been doing is in 30-inch rows, but we also are planting soybeans in 15-inch rows. We're doing it in 30-inch rows so we can use that high-residue cultivator that we talked about. I think the setup, and John had some of this in his part of the presentation. Having no-till coulters and a coulter that slices through the residue is very important. Having a lot of weight on the planter so you can get through the residue. We started using residue managers last year. We actually, at least in Pennsylvania, we started using some Yetter shark tooth type row cleaners. That sort of is a positive and a negative. It certainly improved our crop stands, but what it does is it moves the residue away from the crop row, and so it presents an opportunity for weeds to become established in there more quickly. But I think at least I'm thinking that I'd rather have all the crop seeds establish, and I'll take a few weeds. And then the other part that John had in his was closing wheels. And he showed a couple of pictures there. It's important to have a closing wheel. We've been using spike closing wheels, cast. There's a lot of things. It's really the kind of thing that you can set some things up, but you always want to be prepared to make some adjustments. And you might make adjustments for a certain soil condition one day that is different, a few days later when it's maybe a little drier or wetter.
Okay, we have a couple questions about the roller-crimper. I guess I'll ask them one at a time here. One is, let's see, wait a minute. All right, here we go. When rolling twice, did you go in different directions, and is there a concern with compaction rolling more than once?
So the quick answer is we rolled in the same direction because really, particularly with a crop like rye, you roll and plant in the same direction. So you wouldn't want to. You want to roll with the grain. Is the way I would say it. We did that to help control the cover crops. That's why we rolled it twice. In the case of corn, we actually planted the corn when we rolled it the first time, and then we drove over it the second time a week later, rolling it in the same direction. The roller really doesn't cause much compaction. I would say the tractor tires or the weight of the tractor would be more problematic, but really it's sort of a trade-off, and we are running in the same rows that we have the tire tracks in the same rows that we ran through before, so we really weren't too concerned about it. And you're not running directly on the crop row with the tires, so really compaction wasn't really a problem.
Okay. Other than the description, do you know of any plans that are available or some that could be shared to make a roller crimper?
So the Rodale Institute, which is where we first saw this, they actually had a project. I believe it was a CIG, a Conservation Innovation Grant, back in the mid to late 2000s, and part of that was sort of demonstrating roller crimpers, and I think part of that project was providing plans to build a roller crimper. So I don't know the exact location, but if you go to the Rodale Institute website and do some fishing there, you should be able to find actually diagrams, blueprints on how to construct a roller crimper.
Wonderful. And you can always contact them as well.
Yeah, and Jeff Moyer would be a good person to contact at the Rodale Institute.
Okay. Let's see. Is it not feasible to cut down the cover crop instead of rolling it?
Can I
Ron,
chime in on that
one?
one?
Want to get in on any of this?
I'll make the comment that if the one thing that rolling affords you is the ability to leave the crop where it is, the ability or the need to have a uniform mat across the field is key to make this work. If we were to cut it, there's a pretty good chance that as the planter would be working through that cut off and laid down material, that you would start to kind of drag it and bunch it, and you would leave holes that would result in very easy spots for weeds to come through. So I think that a few folks have worked on it. I guess I've heard mixed results with mowing and planting compared to rolling. The bottom line is you still end up having residue. If it's still fairly uniformly distributed across the field, you're still going to have the challenge of the residue to get through with your planter equipment. Okay.
Let's see. Have you considered winter kill cover crops like tillage radishes and oats as a compromise? Would there be some benefit with the cover crop, although not as many benefits, but more ease in planting? Any studies or thoughts on that?
Yes, we have thought about that and done a little bit of research on that. The problem with winter killed cover crops is they don't produce the residue that we need to suppress the weeds that next spring, early summer. So they can work very well at suppressing winter annual weeds. But by the time May rolls around and we want to plant corn or soybean, in our case, there's just not enough residue to afford us much weed control benefit, and so then we would be forced to have to do some of the things that we have to do in traditional organic systems, such as blind cultivation and lots of inter-row cultivation. But there may be some opportunity with some of those to avoid some of the plowing aspect, the primary tillage, and maybe reduce tillage to some degree. Something we've thought about, certainly.
Okay, we have a couple questions now about varieties of cover crops. For example, one person wanted to know if there are differences in rye or vetch varieties in their performances, or another questioner wanted to know whether an earlier maturing triticale or rye be desirable to enable earlier planting of soybeans.
Go ahead, Ron.
The earlier the maturing, the sooner you'd be able to get in and roll. While that's good on one hand, on the other, we've got to be concerned that it's not so early that the amount of biomass that we're producing is limited. So it's true we'd like to have something earlier so that we could get in and get that planter started in the field a little bit sooner. But if it matures so early that maybe that last 800, 1,000, 1,500 pounds of biomass that we're really counting on to give you that extra couple of weeks of weed control prior to canopy closure, if that never materializes, you're going to be back to having a weedy situation later in the season. So it's good and it's bad. There are some differences between the varieties that are out there. Although I would say right now they're not quite as large as what we might think. In a lot of cases, for many of these species, we're talking varieties within a species, we're talking oftentimes a matter of days difference, and not, week and a half like I think a lot of people would hope for.
Okay, we have a couple questions now about the high residue cultivator that you use. One person wanted to know whether it is feasible for hilly or contour farming.
Well, I think it could be. So the cultivator that we use is actually a machine that's no longer made. That's one of the issues that we're running into now. That those machines were, I mean, they were never widely popular, but they were used particularly in some ridge-till situations back in the 80s and 90s. We have the model that we use is a John Deere. The one down in Maryland and Delaware is made by Sukup, S-U-K-U-P. You can get guidance systems for them, particularly nowadays with some of the precision technologies that are out there, and we don't have that on ours because it's really used in smaller plots, but where you can actually keep it very much on the crop row or between the crop rows, and so that would become, I think, could become pretty important if you have a lot of side hills or a lot of slopes where it might drift downhill some. But I think there's options for actually keeping those in place fairly well nowadays, particularly with some of the precision guidance systems.
Okay, and then the other question about the cultivator we got is whether it has a wide sweep tooth underground that was not shown in the pictures.
So the way that way these cultivators are set up, they have actually a large coulter or disc in the front that basically keeps it straight and running in between the row, and that's followed up by a sweep. And that sweep can be anywhere from 16 to 22 inches wide. It's a wide flat sweep. The idea is that it's fairly shallow. You're running it maybe 2 or 3 inches underneath the soil, and you're undercutting weeds. And so you couldn't see that probably very well in the picture, but basically you're running between 30-inch rows, and so you're trying to get sort of as close to those rows as you can, but obviously you don't want to get too close. And so in our work, at least with our cultivator, 21 or 22 inches is about as wide as we feel comfortable going. Again, if you were using precision guidance, and maybe if you had big flat fields, you could go closer than that. They also do come with weeding discs, which are a set of discs that can run right next to the row, the crop row, and you can either throw soil away from the crop row or throw soil into the crop row. In our system, at least in this system, we're not using those weeding discs because of the heavy cover crop residue. We don't think they would perform very well with that much residue. But in situations where if you're just going through corn stalks or soybean stubble or at least not heavy residue, those weeding discs are pretty important.
And I might also add, Bill, those sweeps that we talk about aren't the sweeps that many of us are familiar with. These things are essentially moldboard plowshares that are attached at a common point in the front, and then you can push them out, allow them to come back in depending on how tight you want to run to the crop row. So hitting the occasional stone does not seem to be an issue for these things. They're up to the task.
Okay. We have some questions from other researchers. The first one is from a researcher in southwestern Ontario. One grower has used rolled rye, no-till soybeans for several years. I'm interested if you can share your research model with our group and be a resource.
Sure. Sure. Are we sharing it with your group today? But we'd be glad to be a resource. I guess whatever that means. I say we're in the process of trying to finish this project up, which will involve not only hopefully publishing some research papers, but also some extension and outreach material. We also hope to continue this project in a new phase, and so yes, we would be happy to share our information with you, whether whether it's through a webinar like today or possibly even in person. So
Okay.
you have my email.
Great. Here's another one. In a recent 2012 paper in Renewable Agricultural and Food Systems by Luna Mitchell and Shrestha, we reviewed the published no-till organic research and discussed the various agronomic constraints facing the crimper roll-down system in organic agriculture, and we had suggested zone tillage or strip tillage as a more promising approach to overcoming these constraints across an array of row crop systems. Do you plan to expand the scope of your work to include zone tillage?
So yeah, that's a very good question. Zone tillage has not been widely tested, at least in this system in our area. I know I saw the recent paper from Wisconsin, and I think that has some possibility. I'm really interested in zone tillage, particularly as it relates to managing some of these heavy cover crop residues. I think there's a lot of potential there. One of the issues I see though is when we do move that residue away from the crop row and produce sort of a tilled zone, we introduce the opportunity for weeds to come in, and so I guess I'm interested in looking at that, but I'm not sure how we're going to manage the weeds in the inter-row.
Okay. Are you guys game for going on a little longer with the questions? I know the presentation ran a little over time. We still have some questions left, so are you okay with keeping going just a little longer? Okay, thank you.
We're fine.
All right, that'd be great. We don't have that many, but still, it'd be nice to get through as many as possible. Do you think there are options where the season is not long enough to allow a cover crop plow down and a cash crop both, or both cover crop plow down and cash crop?
Yeah, I'll jump in on that one. As I talk with growers in the region and around the country, when we start talking about this idea of rotational no-till, my comment is often prefaced with, the further south we go, I think the easier it is to make this system work, because we enjoy, the growers there, as we get down into Maryland and certainly down into South and Central and Southern Virginia, so much longer season that it's not such a challenge for us to be able to get these cover crops established in the fall, after a fairly full, if not a full season grain crop. Conversely, as we work our way, from central Pennsylvania, even just to the northern part of Pennsylvania, maybe just 80 or 100 miles away, we lose the better part of 2 weeks of growing season, and that can make all the difference between, this sort of system working at all, let alone working well, to even consider trying it. It's a much tougher sell as we get into a much shorter season. We're already talking about corn that's sub 100-day maturity. To go much further north, we'd probably be talking about corn that would need to be, in the mid 80-day maturity, maybe even lower. And I'm not sure that we have many varieties out there that would mature in fewer than 82 days right now. There may be a few, but not many. So that is going to be a challenge.
Yeah. Okay. Would a no-till system prevent you from side dressing?
Ron, you want to?
I guess I would follow up. I guess it's tough to ask the question back, but side dressing with what material? If we're talking about organic and we're coming in with manure, actually I know a number of farmers who are coming in and dropping usually poultry manure, pelleted poultry manure, or something like that. It wouthat prevent you from doing it. It might be a challenge to be able to realize all the benefit that you're expecting to get out of that manure, nitrogen, being that you've got all that organic matter on the surface. Banding it, I think, would help to improve the efficiency, help with a little bit of rain to get it down through the residue, solubilize it, get it through the residue. If it was broadcast across the field, I could see where you'd get some of it to the crop, but you'd do a much better job of feeding the microbes that are responsible for helping to break that residue down. And so you might actually melt away the mat, as we call it, even quicker, without really helping the crop if you broadcast. But if you banded it, can't speak from experience, but just from how we understand fertility to work, I would expect that your likelihood for success would be much greater.
Yeah, I would add that, so certainly in conventional systems, in non-organic systems, I'm sure there's plenty of opportunities for side dressing. I don't know why that would be a problem. In organic systems, actually, we didn't mention this in the presentation, but Stephen Mirsky at the USDA in Beltsville is side dressing with poultry litter. They have a machine down there that they can do that with, and so and that appears to be working. There's a group that's done a lot of work with manure application. So I would contact Stephen or send me a note, and I can get you Stephen's contact information, and he could tell you what they're doing down there, because it certainly is happening.
Okay. We have somebody's telephone. We have a couple questions about why wouldn't you just sow a cover crop at the time of the cash crop, or are there studies with buckwheat before the cash crop that shows promise? So it's kind of a different system, but if you want to address that.
Well, so I guess the big reason we wouldn't sow most cover crops with the cash crop is because we would be worried about that cover crop competing with our cash crop, just like a weed would. So we want this period when our cash crop has become established without weed competition, or for that matter without cover crop competition. So there's been a fair amount of work over the years, looking at those kinds of approaches, either living covers, and I don't know of anybody doing that. I guess would be at least doing it well. So they're challenging, trying to grow two crops at the same time, simultaneously, particularly if you're seeding them at the same time. There's a fair amount of work going on with interseeding, where you establish the cash crop and then you come back and seed the cover crop into the cash crop. We can think about that. Happens all the time in wheat in our area, where we come in, we interseed or frost seed red clover into wheat, and that can work very well. There's work looking at that in corn and soybean systems. There's a lot of interest in aerial seeding. So there's a big effort right now looking at other windows when we can come in with the cover crops and try to get them established in cash crops. And that's that's certainly a fertile area for research. We're involved in some of that as other folks are as well.
Okay. I understand, the question says, I understand it's imperative to have a well-developed or level seed bed in order for the roller crimper to work properly?
Yeah, in general, we do call it a roller crimper because it's not just rolling it over. Those blades that you see on the machines, they do, ideally they get down there and they do crimp that tissue in such a way in which it does enough damage that it doesn't really cut it loose, but it keeps it down. And we've had some situations, not in these trials, but in previous work, where the field surface at the time that the cover crop was planted was not as smooth as it could have been. Not that it's got to be tabletop smooth, but tabletop is ideal when you're trying to roll this down and crimp the material all the way across the width of the machine. The rollers, most of the ones that we're working with on farms are either 10 or 15 feet wide. They do make them in various widths, but as you can imagine, as you go to wider widths, trying to cover larger areas, especially with one unit, one solid roller, and you've got dips or valleys. If you've got a little ridge, it's going to cause the roller to ride up so that material on either side of the ridge potentially isn't going to be crimped, and there's the chance, a good chance, that some of that, maybe not all of it, but some of that's going to stand back up again. So it's that extra damage that we get by crimping that vascular tissue when it's down that helps keep it down. And so having a smooth surface so that you get crimping action across the working width of the machine does improve its performance.
Okay, we have time for just a couple of questions because some of the panelists have to go in a few minutes. So let's see. Have offset discs been tested for required tillage and incorporation?
Wow. I'm not sure I understand the question on that.
Yeah, that
question.
Offset discs.
Okay, if someone wants to clarify.
Unless they're I'm not sure.
Okay.
I don't want to speculate.
Okay. Let's see. Do you have plans to dive into complete organic no-till, or are the plans to continue to use tillage as a crutch?
I'm sorry, the last word was as a what?
As a crutch.
Crutch. Oh,
Yeah.
jeez.
Sure, you can have that one, Bill.
Yeah. We would love to dive into continuous no-till, but honestly, in the absence of raising perennial forages, we haven't or maybe it's some perennial crop, we haven't figured out how to manage those systems, at least in our annual grain crops. So we don't foresee, at least with the technology that we currently know about, how we can do that, because we're worried about perennial weeds. I would say that's one of our big concerns, are perennial weeds, and there's other issues as well. So we've been moving toward that. If we were going to redesign the system that we're in now, so again we focused on corn, soybean, and wheat, it would be very easy to add an alfalfa crop or an alfalfa grass perennial crop to that rotation, turn it into a 6-year rotation, and we would automatically have 3 years of no-till. But then we would be back into the grain crop part of it at some point, where we think we need tillage in organic management.
And the other part that I would add to that, Alice, is that to create a good mat, we need to have closely spaced cover crop, and right now we're doing that best with a drill. And as one of our on-farm trials demonstrated a year or two ago, we just really struggle with trying to get good drill action through a fair amount of residue. And so if we're talking about continuous no-till and the buildup of residue over years, just as it was a challenge for us to get soybeans planted through rye, it could also be a challenge for us to get good thick cover established after a 150, 180 bushel corn crop. So it's while it would be ideal, I think it's just going to have some challenges that are going to be pretty tough to overcome.
Okay, well, thank you. We are running out of time right now, so I'd like to thank everyone for your questions and mention once again that you can find this and our many other webinar recordings, some of which are also about cover crops and no-till systems, on our website at the link on your screen. And thanks to everyone for joining us.